After discussing about this optical center, one thing is very clear for us that the ray of light, whenever it enters from the center of the lens, let it be convex or concave, it moves almost undeviated. Here one more point I want to stress, generally these all lens whatever we are discussing about, conventionally we consider them as thin lens. Okay, conventionally that's for our understanding so that there should not be more errors, more lateral displacement, nothing. To understand very clearly and to know the concept more clearly, these all lens are to be considered to be as thin lens. They are very thin lens. Okay, now whatever the distance I am showing here, that only for you to understand that they move parallelly. This is the actual path of ray of light, okay, without this lens, because light travels in a straight path. PQ is an incident ray, right? But once it enters, because this is a transparent dense medium and exactly at the center it is thick and it is almost like glass slab, so it gets little bit deviated from its path, but still it travels in straight line. So it will be exactly parallel to the incident ray which passes in a straight path without any medium. Are you understanding my point? So here we consider all of them as thin lines. So whatever the distance I am showing here, this is also not, it is almost negligible and it is seen as if the ray of light is not at all deviated and it is passing as it is. Because the deviation is so negligible that we don't even understand that deviation, and it looks as if the ray of light, directly passes through the optical center. I have made it very clear about the idea about the optical center. The next one we are going to discuss is principal foci. Okay, we use foci. Foci is a plural word for focus. Okay, that means lens is having two focus. Okay, principal foci. So this lens is having two focus on it, because if this is a lens transparent medium, if this is a lens and on both the sides if it is the same medium, then the ray of light can enter from this side also and this side also, right? So we have to understand, because if it is having two foci on both the sides, now we have to decide for our understanding which is the focal one and which is the focus 2. This is a very clear understanding. Please listen carefully and understand how we are justifying which is the F1, which is F2. Please understand, children. Now this is a convex lens. Let us say this is the optical center. Okay, optical center, and this is the principal focus. This is the principal axis, okay? And we have two focuses on both the sides. As I said you, the light can pass from here also and from here also. If it passes from here, it doesn't get stuck inside, it comes over here, right? If it passes from here, it doesn't get stuck, it comes on the other side. This is the medium one and this is the medium 2. The light which is coming from medium 1 will get refracted with this and passes into medium 2. If the light comes from the medium 2, it passes through this lens, get refracted and comes to medium 1. So for conventional understanding, for our understanding, we keep conventional that on both the sides the medium is same. Conventionally, let us take air. Okay, when both the side the medium is air itself, then the changes are same. That means if the ray of light comes from here and comes on this side, or comes from here and goes on the other side, it will be the same. So we don't find any much difference and it will go easy for us to understand. That is why for our understanding, conventionally, the either side of this lens we keep the medium to be same, and that too which is a very convenient medium, very common medium, that is N. Okay, now we will understand what is principal focal. Okay, so how can we decide which is the first focal point and which is the second focal point? Very important thing. Please see here. First I will discuss about first focal point. Okay, see here. First focal point, that is F1. You might be thinking, what is the importance of this? What makes different if F1 is this side or that side? It makes difference. Okay, we consider F1 for some reasons, we consider F2 for some other assumptions. Okay, so F1 how do we consider? It is the point on the principal axis. Please listen carefully. Okay, first I will write this. For convex lens, convex. Okay, please understand children, for convex lens and for concave lens the assumptions are different. So I will be explaining them in detail. Okay, for convex lens, F1, that is first focal point, F1 is a point on principal axis, such that, now you have to stress here, okay, such that the rays of light coming from it after refraction they become parallel to principal axis. Please understand this very clearly. That is, this particular definition I have wasted little time on writing. Okay, just look into this. Okay. Now I hope you can see clearly the definition. F1 or first focal point is a point on principal axis such that the ray of light coming from it after refraction they become parallel to principal axis. That means it is a some point. Okay, let us consider this conventionally. I stood this side because for us always right hand side is the conventional side. So I consider that F1 point on the principal axis, somewhere on the principal axis on the right side, right? So if I consider this as F1, what do they say? The ray of light coming from this particular point, after refraction, they look as if or they should be parallel to principal axis. Please listen. Suppose if I take this as F1 point, two rays of light are coming from F1, okay, they enter into the convex lens, okay, they enter and after refraction they travel parallel to principal axis. Means if this is the condition or the point where from where you feel that the rays of light are emerging from that point, this point should be on principal axis. The ray of light is seen as if the source, or you can say very simple words I will tell, very convenient, don't want to make it more complicated. Let us consider F1 is source of light. Okay, if F1 is the point where source of light is kept, then the source of light come out from the source of light, rays of light comes out from the source of light. After coming, they pass through the lens, they get refracted, okay, and after refraction, these rays of light are traveling parallel to principal axis. such conditions are accepted, then that particular point is called as F1. That is first focal point F1. So keep in your mind, children, generally F1 is the point, or generally we consider F1 is nothing but the point where you have kept or where source of light is present. Okay, once the source of light, when the rays of light emerge, they travel through the convex lens, and after refraction from the convex lens, they travel parallel to principal axis. Such point is called as first focal point. Am I clear? Right, children? Now we will understand what is the first focal point of concave lens. We understood about convex lens, isn't it? It is the point from where we observe that the rays of light are coming out, emerging out, passing through the convex lens, and after refraction they are traveling parallel to principal axis. Now let us see which is the first focal point to be assumed in concave lens. F1, that is first focal point of the lens, such that the incident rays of light appearing to meet at it at one single point after refraction. So that means, suppose if this is a concave lens, let us say that two rays of light are trying to enter into it. Okay? Because of this shape, as I had discussed, you just imagine this is the prism, this is the prism. Okay, so that means base is outward and this is way. Base is outward, like this it is. Okay, this is one first prism, this is second prism. So when light enters into it, then obviously base is outward, so this ray of light enters and gets refracted like this. Okay, the same way this light also enters and gets refracted like this. But these two, that means they are coming from here outward. Okay, they are coming from somewhere. Source of light is somewhere very far. Okay, the rays of light are coming from the source of light, right? And they enter into this concave lens. After entering, actually they are diverged. They went in two different directions, but still they are appear to meet at one single point. Okay, they are appear to meet at one single point. For concave lens, the point where the rays of light after refraction appear to meet is the first focal point. Because when you draw ray diagrams, you should be very clear with this F1 and F2. You cannot simply take anything as F1 and F2 because on both the side it is same. No. That's why I am stressing on these definitions and making you very clear. Okay. So first focal point for the concave lens, what did we discuss? The rays of light when enter into the concave lens, they actually get diverged. Why I said you very clearly? Because if these two are the two pair of prisms, their bases are outward, so the rays of light will bend away, right? But though they bend away and diverge, but even for us, they are appear to meet at one single point. Appeared. They are not meeting really. They are appear to meet at one single point after refraction. For concave lens, that point is the first focal point. Is it clear?